For today's lesson, we're going to continue with section 5.6 and look at some other log equations. For this first example, we have a natural log. And to start, we're going to begin the same way we did the other day. This is an equation that has logs on one side, so the first thing I want to do is combine those. So it's natural log, and since the second one is subtracted, I have x plus 1 divided by x inside of the single log equals 2. So we're going to get to the point where we have a log on one side and a number on the other, and now we need to change to exponential form. Remember, natural log means log base e, where e is a number that's approximately 2.7. So this is log base e, so our exponent is going to be base e to the second equals the argument x plus 1 over x. Now we need to solve this equation. The whole time I need to remember e is a number, so e squared is just a number. I'm going to solve this the way I normally would. Multiply both sides by the denominator. So I have e squared times x equals, the x's over here cancel, x plus 1. This is a linear equation. It's just like I had 5x equals x plus 1. When I have an equation like this, I would want to get all the x's to the same side. So I'm going to do the same thing here. When I have 5x minus x, I can combine that to 4x. In this case, I can't combine the coefficients because I have e squared as one of them. So this is going to be e squared times x minus x. I want to solve for x. So again, if we go back to our linear equation over here, I would take whatever's multiplying x and divide both sides by it. So here I need to know what's multiplying x. I'm going to factor the x out. I have e squared times x minus 1 times x. So the x comes out front, and it's x times the quantity, e squared minus 1 equals 1. Now I can divide both sides by the coefficient of x, the e squared minus 1. And if I want an exact value, this is my exact value. But then we can go to our calculator and figure out an approximate value for e. I'll go to calculator, and I'm going to take 1 divided by the quantity, e squared minus 1. My answer is about 0.16. Just a quick check, if we go back to the top, 0.16 plus 1 is bigger than 0, and 0.16 is bigger than 0, so that answer works in the original equation. I have my one answer, x is about 0.16. Our second example begins like a lot of the problems we did the other day. I have two logs added on this side, and again, I'm equal to a number. So I'm going to combine these to start, log base 2, and since they're added, I'm going to multiply x plus 1 times x plus 7. And again, I'm at the point where I have a log equals a number. There's one logarithm on this side and just a number on the other side, so I need to change to exponential form. The base of the logarithm is the base of the exponent. Logarithm's equal to the exponent, so it's 2 to the third equals this whole argument. Let's multiply out x plus 1 times x plus 7. X times x, I have x squared. I have x times 7, and also 1 times x. And I have 1 times 7. Now I have a quadratic, and I'm going to set it equal to 0. 2 cubed is 8, so I'm going to subtract 8 from both sides. And I get 0 equals x squared plus 8x minus 1. In the problems the other day, we could always factor this quadratic. In this case, the problem is not factorable, and that'll happen in some of the homework problems tonight. When you can't factor, your next option is use the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have negative 8 plus or minus 8 squared is 64 minus negative 4, 64 plus 4. This is 68 all over 2. And then I'm going to simplify square root of 68. 68 is 4 times 17. So negative 8 plus or minus 2 square root of 17 all over 2. And I have two answers here. I'm going to cancel out the 2. So I have negative 4 plus square root of 17 and negative 4 minus square root of 17. And just a reminder, when you cancel out this 2, I have to divide both the 8 and the 2 in the numerator by 2. So here, I have to look at these answers and go back to my original problem. One of these has x plus 1, the other has x plus 7. I'm going to check negative 4 minus 17. If I put in negative 4 minus 17, or square root of 17, and then I add 1 to that, that's a negative number. I cannot have a negative number inside the logarithm. If I take negative 4 plus the square root of 17, and then add the 1 to it, that's positive, so that answer is acceptable. So I'm going to go back here. The negative 4 minus 17 does not work, so we're going to eliminate that answer. And my only solution is negative 4 plus the square root of 17. So the steps up until this quadratic are the same as what we did the other day, but you may need to use quadratic formula instead of factoring. There's a set of problems that you need to work out of the book on for today. Please make sure that you submit those to Classroom at some point by the end of the day today. And then also make sure that you do the attendance exit ticket, which will let me count you as present for the day today. Thank you.